Welcome back to another exam walkthrough. This is second exam walkthrough in the circular motion series. We're doing 2023 Jan Unit 4, question number 2 and question number 13. You can go through the questions and try them yourself. To see the examiner report and the mark scheme, you can go to the end of the video. So let's start with this question. Laboratory centrifuge rotates at 1,500 revolutions per minute, and you have to give the angular velocity in radians per second. So first I'm going to multiply the 1,500 revolution by 2 pi, because it's like going 2 pi, 2 pi, 2 pi, and that you're doing that 1,500 times. That's what 1,500 revolutions mean. You go in circles 1,500 times, and then you're going to divide by 1 minute is 60 seconds, so 60 times 1. That's going to give you the time in seconds, and then you're going to get the answer as 1,500. Yep, it should be D. And then we have a question on the aeroplane here. They have given us 4 forces: drag, weight, thrust, and lift. Okay, so the lift force is perpendicular to the wings. To change direction, the aeroplane banks so that one wing is lower than the other. The lift force is no longer vertical. The aeroplane flies in a horizontal circle, so it's going to be moving something like this. And then they've given us the horizontal circular path, and then the speed is 52 meters per second, and then they've given us the angle there as 20 degrees to the horizontal. And they've asked us to calculate that the radius of the circular path is 800 meters. They've given us the mass and the speed again of the aeroplane. Okay, I guess the other one is going to be different. So this 52, they don't want us to take into account, so they just want us to keep this in mind. Okay, so first thing I'm going to do is I'm going to draw a free body diagram here. So this is going to be the lift force, and this is going to be the weight. And then we know that there's going to be, it's kind of like an inclined plane here, so we have an angle of 20 degrees. Now in circular motion, you never make components with weight. That's something you have to understand. You always make components with the other force. That could be tension, that could be the lift force. So we want to make components with the lift force. So what I'm going to do is I'm going to need this angle right over here. This angle, let's call it theta. So one thing I know is this is going to be 180. This is going to be 90. And then I just need to find this angle right over here. So this is 90. We know angles in a triangle is add up to 180. So this should be 180 minus 90 minus 20. I want to get this angle right over here, and that should give me 70. So this angle is 70. Now we can find the value of theta. Okay, and that all of this is supposed to give me the value of theta, and the value of theta is 20. So this is 20. Okay, so I hope that clears the angle stuff up. Now let me just erase all of this. Let's draw it all again. So we have this. We have the lift force. This angle is going to be 20. We have the weight, lift, and then we can make it into components, the lift force. So this is going to be L sine 20, and this is going to be L cos 20. You can see clearly that L sine 20 is going to be your centripetal force. So L sine 20 is equals to mv square over r, and L cos 20 is equals to mg. We can divide both the equations. So this is equation 1, equation 2. Divide both the equations. We're going to get L sine 20 over L cos 20 is equals to mv square over r, and then mg. Cancel the amount, cancel the allowed. Sine 20 over cos 20 is tan 20 is equals to v square over rg. So you have to prove this. You have to do all of this. You can't just use the equation straight up. I know most of you have memorized this equation, but you can't use it. You will be awarded only maybe 1 mark at mercy, but the examiner is pretty ruthless in this, and he in the examiner report he has written he's going to award no marks, so better not use this. Maybe you can get a calculation mark or something like that, but don't use that. So you have to derive all of this, and then you're going to get 10 20, and we know the velocity 54 square, and then we have to show r, and then we can put 9.81 there. So we find the value of r, So the value of r is going to be equals to 816 or 817 meters, which is approximately 800 meters. So that's going to be your answer. You can do it other ways as well. You can actually find the value of the lift force and then find the value of r. You can solve it simultaneously as well. Totally fine. Go for it. You'll get all the marks. I did it a bit quicker by dividing the equation. It's up to you, whatever suits you. Okay, and the next question is determine the time taken by the plane to move through 90 degree of the circular path. So 90 degree is going to be half pi. 180 is pi. You can convert it obviously. So 90 is going to be half pi. And then it's given us a speed. So we can, we need to find the value of time here. So we can use v is equals to r omega to find the value of omega first. And then we can find the value of time. So that gives me the value of 0.066 rad per second. And then we can say omega is equals to change in theta divided by change in time. And then 0.066 is equals to half pi and then t. We can find the value of t. And that's going to be 23.8 seconds. So in the last part of the question tells us the wings of the airplane are now leveled and with the diagram showed, and the speed and the magnitude of the lift force remain same. Okay, so now what will happen to the vertical motion? So remember before L cos theta was equals to mg. Now we have the lift force is equals to mg. What I'm trying to explain here is that before a component of the lift force was balancing mg, and now the entire lift force is balancing mg. Okay, it says the speed and the magnitude of the lift force remain the same. So before a component was balancing, now the lift force itself is balancing, right? And actually what I've written here is technically wrong, because if a component is balancing the weight, now we have the entire lift force. It should actually be greater than mg. I hope that makes sense. So we can say the lift force is greater than weight. So there is a resultant force upwards. And they want you to talk about motion. So you're going to write the aeroplane will accelerate upward. Aeroplane. Okay, that's going to give you 1 mark, and the second mark is here. Okay, so I've explained the question. I hope you get everything that's going on in this question. And yeah, now I'll show you the examiner report and the mark scheme. And